Good day, students. Thank you for joining today's class. Today we are discussing a topic titled Homogeneous Differential Equation. Students always find it difficult in identifying homogeneous differential equation. Now, how you identify homogeneous differential equation is by having your dy over dx to be in the form of function of y over x at the right hand side. Now we are going to confirm if x squared plus xy, when it's being divided by both sides and it comes to the right hand side, and after that when we divide both sides by the highest power of x that is having the highest power or highest degree by both the numerator and the denominator. After doing that, after doing the division, we want to see whether it is an homogeneous differential equation or not. Okay, the first thing to do is to divide both sides by x squared plus xy. Now let's write the equation. X squared plus xy dy over dx equals xy minus y squared. Now, the next thing to do, to divide both sides of the equation, both sides by x squared plus xy. You have to remove it from the left hand side and take it to the right hand side. How do you do that? You divide both sides by x squared plus xy. Now have x squared plus xy dy over dx equals xy plus xy minus y squared divided by x squared plus xy. Divide the right hand side also by x squared plus xy. Whatever you do to the left hand side, you do it to the right hand side, so that we can do justice to both sides of the equation. Cancel out. You having dy over dx equals xy minus y squared over x squared plus xy. Now I want to check if the equation is an homogeneous differential equation. How do you do that? How do you get that? You divide both the numerator and the denominator with the x that is having the highest degree. You can see that is a homogeneous differential equation because x has degree of 1, y has degree of 1, which is 2. Degree 2, y also has degree 2, x has degree 2, x has degree 1, y has degree 1. You add the 2 degree together, you have 2. Okay, is an homogeneous differential equation, but that's not uh, how to confirm it uh, very well. How to confirm it is to know whether you have the form of y over x at the right hand side. Let's see. Let's divide it. dy over dx equals divided by the highest power of x. We're having x squared to be the letter, the variable that is having the highest power. We now divide both the numerator and denominator by x squared. Now xy divided by x squared minus second one y squared divided by x squared. What we are trying to do, we want to confirm if it is an homogeneous differential equation. when you know it as an homogeneous differential equation, you can now go ahead by substituting y equals to vx. If it is not an homogeneous differential equation, just go directly to separation of variables. Okay, now divide by x squared divided by x squared plus xy divided by x squared. X cancel one of the x. We have x squared cancel x squared. X cancel one of the x. Now have y over x minus y over x. Let the two be in bracket and square together over 1 plus y over x. Can you see that is an homogeneous differential equation because of the form of y over x, y over x, y over x, constant 1. Has no, when it has a constant of 1, it does not affect the homogeneity of it. It's still an homogeneous differential equation. Okay, you might have 1, 2, 3, and the rest. But what we're after is y over x, y over x, y over x. If you have any of the variable to be y, and it doesn't have y over x, that disqualify it. It's no more homogeneous differential equation. Or you have all the variables to be y over x, except one, which is a constant. It's still it's allowed. Now, since we have confirmed it as an homogeneous differential equation, let's call this one equation 1. Substitute, and now substitute y equals to vx in equation 1. Now dy over dx equals x. You have y here. Let's substitute. Multiply by vx minus vx squared, because your y is being squared, over x squared plus x multiplied by vx. Now it to be vx squared minus v squared x squared divided by x squared plus vx squared. And let's factorize out. Dy over dx equals x squared is common, x squared into v minus v squared divided by x squared into, yes, we have 1 left, 1 plus v squared, 1 plus v, 1 plus v, x squared cancel out. We are left with v minus v squared over 1 plus v. Okay, let's call this one equation 2. From here, we can now differentiate y equals to vx using product rule. And you now have dy over dx equals, you keep this v, you differentiate x first, keep it like this, dx over dx, when you are using product rule, is addition in between them, plus now keep this x and differentiate v, dv over dx. Take note that x is an independent variable, and its derivative with respect to x is always 1. The derivative with respect to x is always 1. That's why I will put 1 here in the next line, while dv over dx will be left the way it is because this v is a dependent variable and its derivative depends on how it varies with x. And because of that, there is no universal value for it. That's why it will remain the way it is. And you now have v to be equal to v into 1 plus x dv over dx. dy over dx equals v times 1, that's v, plus x dv over dx. Let's call this one equation 3. Now, we have this dy over dx to be in terms of v. We have done justice to this differentiation, and likewise we have substituted vx into equation 1 to get this equation 2. Since they are both dy over dx expressed in terms of dy over dx, you now equate them together. Equate equation 3 and 2 and equation 2. When you do that, now v plus x dv over dx equals to v minus v squared over 1 plus v. Take v across the equal sign, it returns to negative. X dv over dx equals v minus v squared over 1 plus v minus v over 1. Now let's look for the LCM. Now LCM to be 1 plus v. 1 plus v in 1 plus v is 1 times v minus v squared, that's v minus v squared. Put your negative, 1 goes in 1 plus v, that's 1 plus v. You put your minus v here, and 1 plus v times v. That's why I will put it inside the bracket. 1 plus v. Okay. Now x dv over dx equals v minus v squared minus v times 1, that's minus v times v minus v squared over 1 plus v. V cancel minus v. We're left with minus v squared, that means we have minus 2v squared over 1 plus v. Now you have x dv over dx to be equal to minus 2v squared over 1 plus v. Now what you need to do now is to carry out what we call separation of variables. Separation of variables. Well, I must have similar expression to come to one side. Now I want the v and expression of v to come to the left hand side and the x and x to move to the right hand side. I have to cross multiply. Cross multiply. Cross multiply. When you do that, you're having x into 1 plus v dv equals minus 2v squared dx. From here, you can see that we need to take v squared to the left hand side, divide both sides by v squared. Now have x into 1 plus v dv divided by v squared equals minus 2v squared dx over v squared. V squared cancel v squared. You're left with x into 1 plus v dv over v squared equals to minus 2 dv. You divide, you see that x has to leave this side, but before it leaves the divisible side, divide both sides by x. Divide both sides by x. Doing that, you now have x into 1 plus v dv divided by x v squared equals to minus 2 dv over x, sorry, 2, what you have here, sorry, this one, this place dx, you can see it here, dx, having dx, this side is dx, having here, from our expression, as we are coming, having dx, okay, now x cancel x, we are left with 1 plus v dv over v squared equals minus 2 over x dx. Now we have carried out separation of variables. You can now integrate both sides. Integrate both sides. Integrate both sides. Now integral of 1 plus v over v squared dv equals integral of minus 2 over x dx. Now this v squared is common to 1 and v. Now integral of 1 over v squared plus v over v squared dv equals, this minus 2 is a constant, let it come outside the integral sign, minus 2 integral of 1 over x dx. Now in indices, you apply indices, this 1 over v squared will be v raised to power minus 2. When you are removing this reciprocal, you introduce your negative 2. This v cancels one of the v. You have plus 1 over v dv equals to minus 2 integral of 1 over x dx. Now, when you are removing the integral sign, it will be v raised to power minus 2 plus 1 over minus 2 plus 1 plus ln v. When you differentiate v, you have 1. Integral of this 1 over v will give you ln v equals minus 2 ln x plus a constant c. Now you're having v raised to power minus 2 plus 1, that's minus 1, minus 2 plus 1, that's minus 1, plus ln v equals minus 2 ln x plus c. This one will now be minus 1 times 1 over v. We had kind of indices. When you remove the negative 1, you have to introduce 1 over 1. 1 into the expression. should now be reciprocal v plus ln v equals minus 2 ln x plus c. Now have minus 1 times 1 over v, that's minus 1 over v plus ln v equals to minus 2 ln x plus c. Now from y equals to vx, make v the subject of the formula so that you can substitute back. V equals y over x. Substitute. Let's call this one equation 4. Substitute v equals y over x in equation 4. Please don't forget to substitute back into your equation before you round up. Now we have minus 1 over y over x plus ln y over x equals minus 2 ln x plus c. Now don't forget that y over x, they are together. Let's simplify this. 1 over 1 divided by y over x, because 1 over 1 times this x will go to the denominator, this y will come to the denominator, which is x over y, which is x over y. Don't forget that we have a negative here, negative sign. We have it to be minus x over y plus ln y over x equals to minus 2 ln x plus c. Now I have it to be, I want the positive sign to come first. Ln y over x minus x over y. I want to take minus 2 ln x across the equal sign turn to positive, plus 2 ln x equals to c. This is the end of our class. Thank you for watching. See you in the next lesson. Please don't forget to drop your question in the comment section. Have a wonderful day.